Okay, so we've got a question here. We need to find these integers here, a, b, c and d. It's 42a plus 33b plus 70c plus 77d equals 1. So how are we going to go about finding these integers? Well, we're going to use something called Euclid's algorithm. So when it's for 4 integers, we need to pair up 2 integers. So what we're looking for is some that have common factors. Well, the one that strikes out straight away is 33 and 77. So I'm going to pair those two, and the other pair, 42 and 70, I can see these have got common factors. So we have to write these down in the way of Euclid's algorithm. So let's start with the 42 and the 70. So using Euclid's algorithm, we can say 70 equals 42 plus 28 remainder. Okay, so now in the usual method, bring this 42 across. So 42 equals 1 times 28 plus 14. And we keep going, so we get some sort of indication of the greatest common divisor. So now we get 28 equals 14 times 2. So therefore GCD of 70 and 42 is 14. Okay, now we'll go with the other pair, 77 and 33. So 77 equals 33 plus 44 remainder. Okay, now bring them across 33. 33 equals 44 minus 11. And then bring the 44 across. So 44 equals minus 11 times minus 4. So basically it's 4 times 11. So G, C, D of 77 and 33, that equals 11. Okay, so we've got these numbers here now, 14 and 11. We have to use Euclid's algorithm on this pair of numbers now. So now what we say is 14 equals 11 plus 3. Okay, bring the 11 across. So 11 equals 3 times 3 plus 2. Okay, so now we can say that 3 equals 1 times 2 plus 1. Okay, so now what we can do now, we do the backwards form of Euclid's algorithm on this. So bringing this 1 to the front, so if we put this in its own little box, we're going to use that. 1 equals 3 minus 1 times 2. Okay, so now we know what 2 is. We'll say 1 equals 3 minus, and then for 2 we're going to substitute in 11 minus 3 times 3. We need to keep this 1 here, so minus 1 times 11 minus 3 times 3. Okay, simplify this up a little bit and we get 1 equals, now we've got minus 1 times 11 and we've got minus 1 times minus 3 times 3, so that's a plus 3 times 3, and there's one more here, so now we've got 4 times 3 minus 1 times 11. So if you do a quick calculation on that, you'll still see that we've got 1. Okay, so 1 equals 4 times 3 minus 1 times 11. Now we know what the 3 is. The 3 is 14 minus 11. And our goal is to end up with the 14 and 11 in the final sum. We've already got the 11, now we need to get the 14. So this is how we do that. So now just bring in a bit more room. 1 equals 4 times, now 3 is 14 minus 11. So let's just get rid of that multiplication sign. So 14 minus 11 minus 1 times 11. Okay, now we just simplify this up a little bit. 4 times 14, that's fine. So 1 equals 4 times 14. 4 times minus 11 minus 1 times 11. So now that gives us minus 4. Minus 4 times 11 times minus 1, that's minus 5 times 11. Okay, so then that is the calculation that we need. So that's 56 minus 55, that's going to give us 1. So that's all good. Now we need to do the backwards form on these and see if we can get something that we can plug into here. So we've got a 14 here and we've got an 11 here. So there's an 11 here and there's a 14 here. Okay, so we'll start off with that. So here we can say 14. See, this one here is our final answer. This one here is our final answer. So this is where we're going to start. So 14 is 42 minus 120, minus 1 times 28. So 14 equals 42 minus 1 times 28. Okay, we got the 42, that's good. We need to find a 70 now. So now as we got the 28 here and the 28 here, we can plug in for this. So now we say 14 equals 42 minus 1 times 70 minus 42. Okay, now we just simplify up. So 14 equals minus 1 times minus 42 gives us a positive 42. So then that's going to give us one positive 42 and another positive 42. So that's 2 times 42 minus 1 times 70. And as we got the 42 and the 70, which is what we want to do in the backwards form, we've now got a 14, a 42 and a 70 we can plug in here. So that is looking good for us there. Now this one, let's do this on the backwards form. So now we say 11 equals 44 minus 33, or we can say minus 11 is 33 minus 44. Let's stick to the positive number. So we'll say 11 equals 44 minus 33. Okay, so we've got our 33. We don't want this 44, we want the 77. So let's plug in something for 44. Well, we know that 11 equals 77 minus 33 will give us our 44. So that gives us 1 times 77 minus 33 minus 33. So now we know that 11 equals 1 times 77 and minus 1 times 33 plus another minus 1 times 33. So that's now going to give us minus 2 times 33. You can just plug this in a calculator or just work it out in your head. You'll see that this is a correct statement. Okay, so now what we're going to do, we're going to plug our values for 14 and 11 and our algorithms into this. So let's give ourselves a bit more space. So now what we say is 1 equals 4 times. Now instead of 14, we're going to plug in this. And then minus 5 times 11. And instead of 11, we're going to plug in this. Okay, so we're well on the way now. We've got something now with a 42, we've got a 70, a 77 and a 33, and it equals 1. So we're well on the way now. So what we're going to do now is try and simplify this up. So we've got 2 times 42 times 4, that's going to give us 8 times 42. And then 4 times minus 1, that's going to give us minus 4, and that's times 70. Okay, minus 5 times positive 1 times 77, that's going to give us minus 5 times 77. And a minus 5 times a minus 2 is going to give us 10. 10 times 33, is what we're going to plug in. So plus 10 times 33. Okay, now this is equal to 1. Now what I would like to do here is just plug in some values here of what we've got on this sum and see if it comes to 1. So 42 times 8, that's 84, 168, 336. Minus 470s is 280. 77 times 5, that's 385. And 1033 is 330. Okay, so we see the difference between these is 56 and minus 385 plus 330. So that's going to give us a negative 55. Okay, 56 minus 55 most definitely is 1. So therefore we've got this bit here, we've got this bit here, this bit here, and this bit here. So now we can say that our A, that will be the coefficient with 42, which is a positive 8. So A equals positive 8. B is with 33, so that's a positive 10. C is the one that goes with 70, so that's a negative 4. And D is the one that goes with 77, which is a negative 5. Okay, so that is one of many solutions to this question here. So 42A plus 33B plus 70C plus 77D, plug in these, that will give us our solution of 1. If you try different pairs, maybe you might want to pair up 42 and 33, which you could do because that's a common divisor of 3. And this one here, 1777, has got a common divisor of 7. You'll get a different solution.